Hello and welcome to the second episode of my compiler tutorial series. So in the previous episode we discussed the overall overview of making a compiler. In this episode we're going to be making the Tokenizer. So I'm going to be using IntelliJ for this project and Java. So it's going to be Java version 8 plus. I'm not sure exactly what we'll use, but it doesn't really matter because we won't really use any features of any significance, but we'll see. So JDK, so technically JDK 18 we'll be using. So we'll make a new project, call this graph tutorial, and create that. Okay, so the very first thing that we're going to do is we're going to make a new directory called res, and we're going to assign this as a resource directory in our project. So tag as resources, and then in the resources directory we're going to make a new file which is going to be called main.graph. I've already copied the text for the graph program from previous episode, but yeah, so just some text like this. In my case, I've got some syntax highlighting, which you can configure in IntelliJ, but I'm not going to be showing you how to do that because it's a bit redundant. Okay, so the first thing we want to do is just get that text as a string. So we'll get string program text and go files.readString path of res. Whoops. res.graph. Since this throws an exception, we'll need to just put try catch around that, and then we can print the program text. Okay. So for some reason, program text is equal to that, and then run this. Okay, cool. So we've got that. So the first thing we're going to do in terms of classes is we're going to make the token class. So class called token, and this is going to have an enum, so public enum type. We're going to have a type, and we're going to have index and a length, and we want to make these these all public. Okay, in here we're going to start defining the different types of tokens. So starting with identifier, which, as I mentioned before, is anything that's user-defined word for a variable or function or whatever. We've got number, string. Then we can start defining some of the statically knowable ones that have fixed string values. So to make this a bit easier, we're just going to do a few things. So we're going to add a string. So we're going to close this off. We're going to add a string text parameter to this enum, and then we're going to add two constructors. So type with no argument, in which case text will be set to null, and another constructor which takes a string text, in which case we'll say this.text equals text. And now we can add arguments to our enums in the form of these strings. So we're going to start with some obvious ones, which are white space. So space, new line, tab, \t, carriage return, which is sort of a Windows specific thing. And I think that's all for white space. Then we want to start doing some of the punctuation. So colon, semicolon, got forward arrow, backwards arrow, we've got open parenthesis, close parenthesis, open brace, okay. We've got, what else have we got? So I think that's all the major ones, and then we obviously need the maths operators, so plus, minus, plus minus, multiply. Well, actually, we'll call this star. So star, forward slash, and what else have we got? Forward slash, and equals as well. Okay. And then we also need the keywords. So while, for, if, else, struct, true. So this is for the literal true and false. Okay, and I think we should be okay for that. I'm also going to make two small helper functions. So one for evaluating if a type is white space, so public boolean is white space. Return switch this case, new line, true, default, false. Then in here we'll just put the rest of these, so space, tab, carriage return. And a second one for keywords. So public boolean is keyword. Return switch this. Case, while, true. While, for, if, else, struct, true, false. Okay. So I think that should be everything. Right. So the next thing is we want to actually make the procedure to do the tokenizing. So we're going to make a procedure called list token tokenize. It's going to take in a string program text and just import that. Cool. Right. First thing we're going to do is make the list of tokens that we're going to return. And now we're going to just start iterating over the text one character at a time and adding to this list when we encounter a token that matches the text at that point. So to be able to check through the tokens, we're first just going to make some arrays or some lists to store the different token types. So we can make a list token.type search tokens or search types, and a list of tokens for keyword types. Sorry, I shouldn't say list token types for the keyword types. Then we're going to iterate over all of the token types. So for token.type token type in token dot type values if token type dot text is not equal to null. So if it has actually some sort of predefined text value, then we're going to check if it's white space, or not white space, sorry, if it's a keyword. If it is a keyword, then we add it to the keyword types. Otherwise, we add it to the search types. No, token type. Oops, there we go. Right, so now we've got our arrays sort of set up. Now we are going to write the loop. So I'm going to say for int I is 0, I less than program text dot length I plus plus. We're going to say for token dot type search type in search types, and for each search type we want to check at that index, does it match the source text. So we're going to write a small helper function to do that. So we're going to make a helper function called boolean matches. This is going to be static as well. In fact, I should have made this static as well. And this is going to take in as arguments the program text is the first argument, the search text is the second argument, and the text index is the third. Okay, then we're going to iterate over the search index. So int I equals 0, I less than search text dot length, I plus plus. We're going to say character A is equal to the program text at the text index plus I. So we're going to increment along with the text for the program text. It's going to be offset, and the character B is just going to be equal to the search text at I. And it's quite simple. If these don't match, so if A does not equal B, return false. And then if we never return, false, then they must match. So we return true at the end. Okay, and we'll use that here. So we'll say if matches program text search type dot text I, then make a new token index is equal to, actually, first of all, token type is equal to the search type. The index is equal to I, because that's where we found it, and length is equal to the search type dot text dot length. And then we can just do tokens to add token. And then finally, we want to increment I by the token length -1. So the reason why we do this is so that when we deal with tokens that are more than one character long, we will sort of jump over the extra characters, because by default, since we're in this for loop, we already jump over a single character each time. So yes, that's why we do that. And at the end, we just want to return the tokens, like this. Then here, just to test this out, we're going to say list of tokens is equal to tokenize program text, like that. And just to see what is in this, you can make a for loop. So for token in tokens, just print the token type. Okay. So just run this and see if that works. Okay. So you can see here now we have the program text, and then a list of stuff. So we've got space, colon, colon, space, open brace, carriage return, new line, da 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 da. So I think this is all being done correctly. However, you'll notice we don't have any identifiers, and that's because we didn't actually provide a way to parse them yet. So we're going to do that now. So we're just going to make an index here, which is called last token index. Set that to 0. And then whenever we actually encounter a token, before we add the token to the list, we're going to check if there's a discrepancy between the last token index and the current token. So if last token index is less than I, then we want to add an identifier that represents the gap between where the last piece of punctuation was and where the text index currently is at, or I is currently at. Then also to fix this, we want to set the last token index to equal to I here as well. Actually, I plus equals, no, so this will be I plus 1, because it's sort of the end of the last token. So now we can say if this is less than I, then token identifier is equal to new token. Identifier.type is equal to identifier. Identifier.index is equal to last token index, and identifier.length is equal to I minus last token index. And then we can just add that to the list. So tokens.add identifier. Okay. That should parse that correctly. However, we also want to just make doubly sure by seeing what the actual text is. So to do that, instead of doing this, we're just going to do this instead, where we say string type text is equal to token.type text. Not text, sorry, name. Then we're going to say string token value is equal to program text substring token.index plus token.length. So this is going to get the actual value from the source text of what this token represents. And then we're just going to say if token dot type actually, in fact, what we will do is set this to null first, or empty string. We'll say if token.type equals identifier, then set it here. So token value is equal to this, and then we're going to do a printf essentially, and we're going to say so %s for the first argument, which is going to be the type, second %s for the value, and we're going to say type text in here and token value here. So hopefully what this should mean is that every, I've got a semicolon there, every token is printed out, the type of the token is printed out first, and then only in the case of identifiers do we actually print the value that it represents in the text. So run that, and yeah, you can see here, if we scroll all the way to the top just to make sure, so we've got identifier vector2 space colon space identifier struct space open brace carriage return, etc. identifier x as well. So it's definitely parsing the identifiers correctly. However, it's also parsing other things as identifiers. So it's parsing structs as identifier when in fact there should be a keyword called struct. It's also parsing, well, we've got an error here because I forgot to add comma, which I'll need to add now. But it's also adding numbers as identifiers as well, which is also isn't correct. And then lastly, it's also not parsing strings correctly, because it's first of all parsing half the string as an identifier, and then it's also actually parsing the space in between the string, which isn't correct either. So we'll need to fix all of those things. The first thing we're going to do is just add the remaining punctuation that I forgot to add. So that's going to be comma, dot, and I think we'll leave it at that. We could add other ones, but we're not using any other ones for the minute. So we've done that. The next thing that we want to do is fix those numbers, I think. So, in fact, actually no. Let's fix the keywords. So after we find this identifier here, before we actually add it to the list, we just want to sort of check that actually this identifier isn't a valid keyword instead. So we want to say for token.type keyword type in keyword types if matches program text keyword type.text I. Actually, it would be last token index, sorry. Then we can set the identifier type to be equal to the keyword type, and then break. So that should fix keywords. We can just double check, see what happens. So if we scroll to the top here, you can see we have identifier vector2 space base colon struct. So it's printing out the keyword type, not the actual, not representing it as an identifier. So that works okay. The next thing that we want to do is sort out numbers. So we're going to make another small helper function called static boolean isNumber. It's going to take in program text and an index for where the number starts and a length of how long the number is. And we're just going to say for int I equals 0, I less than length I plus plus, char c is equal to the program text at the index plus I, and then if c is less than the character of 0 or it's greater than the character of 9, then we return false. And similarly to the other function, if that all goes through, we return true at the end. So yeah, it should be relatively simple, but we're just doing the same thing or a similar thing, but for numbers, just iterating over a certain range in the source text and saying, are all of these indexes numbers? And if they're not, return false. Right, so down here, after we do the keyword stuff, we're going to say if isNumber, program text, and this time it's going to be identifier.index and identifier.length, then identifier.type is equal to number. And I think in here we can actually have identifier.index as well, just to make it a little bit clearer, or more consistent. So yeah, we can try that now as well. So if we scroll up, yes, we should get number. I think also what we might do is actually change this. So we say if it's an identifier or token.type is equal to number, just so that we can see what those numbers are. Yeah, so number 4, number 1, etc. And we've got also correctly parsed the comma out as well. Okay, so that's good. The last thing that we need to do is parse strings. So to do that, we're going to start at the top of the for loop here, and we're going to check to see if the current character is a quotation mark, and if that is true, then we're going to go into a separate loop that keeps parsing until we find the end of the string. So if program text character at I is equal to quotation mark, then we're going to keep track of a new index, so we're going to say int string search index, and that's going to be equal to I plus 1, because we want to skip over the current quotation mark. I'm going to say while string search, or actually while program text character at string search index is not equal to a closing quotation mark, then we're going to increment the string search index, and then once we find the closing quotation mark, we're going to increment the string search index again, just to consume that ending quotation mark. Once we've done that, we're going to make a new token. So token string is equal to new token. String.type is equal to string. String.index is equal to the equal to I, because that's where we started. And the string.length is equal to string search index minus minus I. Okay, and then similarly to sort of when we find a regular identifier, a regular token, we want to both skip over the remaining token, the remaining characters, and then also set the last token index to the correct place. So last token index is going to be equal to string search index, I think, plus 1, and then we're going to increment I by the string length minus 1. So I think that should be okay. Actually, no, so we want to, that's not quite right. So we want to do this first, and then we want to do it I plus 1 here. Yeah. Okay, so I plus is equal to string length minus 1. Yeah. And then, yeah, I plus 1. Okay. So, I think, and then we actually want to add that token as well. So we want to say, probably before we do this, we want to say tokens.add string. Okay. So let's run that. I think before we run that, we're also going to want to just add string to the list of types that we care about printing the value for. And you can see there we've got string hello world, and it's captured also the quotation marks, and then straight after we've got the closing parenthesis. So yeah, that's sort of my well, that's it basically, and I'll see you in the next episode, in which we'll be doing the syntax tree generation, or sort of the more general parsing. Yeah, I hope you had hope to see you then. So thank you very much, and goodbye.